Okay, let's do a couple practice problems on these new nonlinear systems. So how many solutions can there be in a system of equations that has one linear and one quadratic? So again, we might have a quadratic and a linear that never touch. So this would be called zero solutions or no solutions. What if we had a quadratic and a linear that touch exactly only at the vertex? We would then say it had one solution, it touched once. And then finally, what if we had a quadratic and a linear that touched twice? We would say these have two solutions. So our options for these systems is that they have 0, 1, or 2 solutions. Okay, now let's go find the solution on a couple of examples that are already done for you. So in these, they're already graphed. Find the solutions of the system. Again, we're looking for the place. So the solution is the points of intersection. So here I'm seeing 1 point right here and 1 point right here. So we just name those points. So do you see that that one touches at about -4, -7, and that this guy over here touches at 3, 0. Take a second to do the next one. What would you say these 2 points of intersection are? Pause the video and try and get those. And good job. This one touches at -4, -7, and at 4, 9. How funny that they use the same point. Anyways, looking at the next one, it kind of goes to the next page again. Okay, for this one, the quadratic graph is already shown. Graph the linear equation and then find the solution. So the linear equation is y = x + 3. So again, my slope is 1. My y-intercept is 3. So go put a dot at 0, 1, 2, 3, and then count a slope of 1. And now we can see that the places where these touch are at -3. Oops, you guys see what Miss Sanchez did wrong? These are scaled by 2's again. So 1, 2, 3, 0, 3 would only be right here. And then slope of 1 would be up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1, down 1, back 1. So ignore that first line, everybody. This was scaled by 2's. Ignore this guy. So now I can see they're really touching on corners at -3, 0 and at 2, 5. All right, for this next one, graph these 2 different ones and then see where they touch. Notice that the factored form of this quadratic would be this, so they're giving us a hint to help with graphing. So beginning at 4 and a slope of 1, so again, this is scaled by 2's, be careful on that. So 0, 4 would be my y-intercept and a slope of 1. Here's the linear piece. And then if my factor is a +4, my solution would be -4. My factor is a -2, my solution is a +2. Then if I average those, I get -1, and then if I plug in that -1, I get -9 as my vertex. So I'm going back 1 and down 2, 4, 6, 8, 9. And then my two solutions are right here and right here. Sorry, back 1 and down 9 is going to be right here. So then I'm going to connect that and that. And so it's nice and clear right here. One of my solutions to the system is right at that 0, -4, 0. And my other solution to the system is up here at 2, 5. Okay, again, feel free to use Desmos. If you're sketching of the graph, it's hard for you to tell where those are touching. All right, on this last part, we are going to be doing the algebra, figuring out where these are touching exactly by using the algebra. So taking the 6x and plugging it in, and then minusing it from both sides, what times what equals 12 and adds up to -13. My two factors are x minus 1, x minus 12. So my solution is 1 and 12. We now need to take those and plug it back into the linear piece to get the y value. So my two solutions to the system are 1, 6 and 12, 72. So there's my two solutions. Doing the same thing over here. I'm going to be adding 2x to both sides and subtracting 8 to make it equal to 0. What times what equals 10? Hope you're thinking 2 and 5, both with negatives. So we get x minus 2, x minus 5. So my solution is a 2 and a 5. Now we take that and plug it into the linear piece. So we get -2 times 5 is -10. -10 plus 8 would be -2. Sorry, I couldn't read my own writing there. All right, so we get 2, 4 and 5, -2. These are my two solutions to the nonlinear system. Remember to pause the video and go try these and then check your answers to see how you did. Okay, this one, because you'll notice it is not factorable, needs to get plugged into the quadratic equation. So get your A, B, and C. Opposite of B b squared all over 2 times a. So this is no real solution. That means that the graphs do not intersect. So this is what it would turn out to look like if they were a line in a parabola that never touched. It would have a negative discriminant there, and it was not factorable, so we knew something weird was happening. All right, I'm going to make another video for these two. I want you to try them on your own and see how you do. Plug this in, see how you do on these two.